So a refinery, right? It's an oil refinery. They refine oil so that it's gas that cars can actually use to drive and to run their engines. Produces 4,000 barrels per week. So that means every week. Okay. The output is decreasing by 15% each week. So 15% each week, it's dropping by that much each week. State the equation for this situation. I will tell you that this is exponential. I believe that all of my questions tell you what to do, and if not, you're going to have to look carefully, look at the scatter plot. Okay. So you've got two options. Option one is make a table of values where you come up with 3 points that's going to help you come up with a regression. So we've got time in weeks, and we've got barrels. So this is sort of like doubling time, half-life, except for we're not doubling, guys, right? We're not doubling. We're not going half of what we had before. It's just an arbitrary 15%. It's just 15%, right? So you got to watch out for that. So at time 0, at the very beginning, we make 4,000 barrels. And then a week goes by, and we're making less, correct? There's less. So up to you how you want to do this on the side. I'm going to go 4,000 times 0.15. Like, we're going to figure out what's 15% in this case. And it is, if you do the math, I already did it, it's 600 barrels of a drop. And even if this is a decimal, we still use the decimal right now because we're trying to model the situation. Okay, so what happens here is you're going to go minus 600. Like, you go from 4,000 to 3,400. And you need one more. Okay, exponential regression needs at least 3 points. So another week goes by, and this is going to drop again, right? How much is it going to drop by? It's not going to be 600 because it's always 15% of what you had before. So we're going to go 3,400 times 0.15. I'm going to do the math here. That's 510 barrels of a drop. So I'm going to go minus 510. That means that week 2, you're only making 2,890 barrels. And now you have everything you need to perform a regression. So you go L1, L2, and we're going to go stat, calculate, exponential regression. Let's figure out what it is. And let's see if we see something in our equation that you're like, oh, I could have made this one up. I could have known this, that this is the answer. So let's try this. Stat, edit. I already entered all of this. Right? So you go stat, edit, L1, L2, right? You enter those points. And then you press statistics, so stat. You go to calculate, and exponential regression is hidden. It's like way down, like that's at your exponential regression. You hit enter, second 1, comma, second 2, comma. This is always the same, okay? The L1, L2, Y1, when you do a regression, is always the same for me. Hit enter, and there's your equation, which is 4,000. Would that make sense to you that it's 4,000? That's our initial amount, right? How much we were making at the very beginning. So that checks out. And then what's in the bracket? 0.85 to the x. Could we have predicted that it's at 0.85 in here? We could have, because remember, this is less than 1. And if you go 1 minus this, you would realize that it's a 15% drop every week, right? So this, we could have predicted this without a table. If you are able to figure this out without a table, go ahead and write it. So option 2, since we have the percentage drop, this is big here, per week. So they do tell you what it is for every time period, for every unit that goes by. Just write equation, okay? We know that A is equal to 4,000. We know that B is 1 minus 15%, which is 0.15. That's 0.85. And then you just go ahead and write it. It's 4,000, 0.85 to the x. Regardless of how you go about it, you arrive to the same answer. Everybody's going to get the same answer. And I'm going to warn you, once you copy this down, some of you are going to try to do this the same thing with half-life or doubling time. Don't do it, okay? The reason why is because you're doubling time. So let's say the half-life is what, 50% of what you had before, right? So some of you might say, oh, then it's 0.5 in here to the x. But half-life, the years or the weeks will not be per week. You know what I mean? It'll be the half-life is 13.5 weeks, let's say. You know what I mean? So you don't have the amount decrease per hour or per second. So when it's doubling time or half-life, don't do this. Okay, when it's doubling time or half-life, always go to your table. Make a table. In fact, if you're not sure, always just make a table and you'll be safe. Okay. If it's one of those questions where you're supposed to come up with the equation, make a table and then you'll be on the right track. So similar to doubling time, but I will show you, right, that it's not. Doubling time and half-life, we did one of those on page 19. With half-life, right, we were told that half-life is 30 years on page 19. 30 years, right? So we start with 0, it's 100%. 30 years go by, you're down to half. Another 30 years go by, you're down to half. So see, you see the jump here? It's not, you're not going up by 1 on the left side, right? So that it's different. So don't be just writing your equation out of nowhere. Make your table and come up with what you need there. Okay. If you want to try this particular one again, let's go back to 24. I believe I have one on page 30. Let me just double check. Yeah, page 30, which is similar. So if you want this, I'm going to put at the bottom, try page 30. If you want a question like this, I only have one, I think. It's rare that it shows up on the exam, but I want you to be prepared just in case. Okay? Stop there. So I call this an oddball.